All right, in topic 4.2, we'll take a look at irrational numbers. In previous math classes, you've talked about rational numbers. Now we're going to move up and take a look at irrational numbers. So the definition of an irrational number is anything that cannot be written in fraction form, m divided by n, where n clearly is not 0 and m and n are integers. And the decimal representation of that irrational number neither terminates nor repeats. So for example, pi is an irrational number. There's no repetition and the decimals go on forever and ever and ever and ever. So if we take a look at a few examples here and try to figure out if they are rational or irrational. So if we look at part A, that's already written as a fraction, -3/5. So if it's written as a fraction, if it can be written as a fraction, we know that it must be rational. Now if we look at part B, the square root of 14, if we grab a calculator and we calculate that, we get 3.74165737, and I'm sure it carries on onwards and upwards. So there's no repetition. We can assume that decimal goes on and on and on and on. So the square root of 14 will be irrational. Now part C is a little bit tricky. We have the cube root of a fraction, 8/27. We can rewrite that fraction, or that cube root, sorry, like this. So we have the cube root of 8, all divided by the cube root of 27. Now we know the cube root of 8 will be 2. The cube root of 27 is 3. So we have simplified that cube root into a fraction, and any fraction of whole numbers will be a rational number.